Okay, so what we're going to be talking about in geometry today is triangle congruence proof. Okay, so here's your first page of your notes, so make sure you have that in front of you, and I'll let you know when it's time to switch over to the second page. As you go, it should match up mostly with what we're seeing on here, but there are a couple questions to be answered as you finish, as well as you can answer them as we go through the lesson. Okay, so if you remember earlier in the year, we looked at trying to create triangles that had two things in common. For example, we might have two triangles that had a 5 centimeter and a 8 centimeter side, and seeing if in doing that we came up with triangles that were exactly the same no matter what. And the fact is we didn't. And the reason for that is when you had certain sides, for example, you could have had a side that was this long and a side that was that long. However, there was no rules as to how you tilted them, so you could try to create pretty much the same side, but then the other side of the triangle, even though it was the same length, could have been tilted much more in. So what occurred is we didn't come up with even triangles that were similar, let alone congruent triangles. The reason for that was it was only two sides. We did, however, discover that if all the angles in a triangle were the same, were congruent, then those created triangles that were similar, meaning same shape, but not necessarily the same size, because there was no rules as to how far apart the angles would be from each other. So even if we had different angles, we could move them farther apart. My contention, and this is one of the things that I want you to think about, is why is it that angle alone is the same as angle? Why do we not need to have all three in a triangle? So that might be something to think about for a second. And try on the paper, you can see why is it the same. So pause it for a second if you need to, and we'll think about why that does in fact create the same thing. Okay, so if I take three random sides, okay, and I'll just draw myself a triangle here. As you can see, it has three angles. What I'm saying is if I take another triangle that ends up being similar, we'll assume those are similar, what will occur is that this angle and this angle will be equal, as well as this angle and this angle will be equal, and thirdly, this angle and this angle would be equal. When that occurs, we end up with two similar triangles. My contention is that we don't actually need that. And the reason for that is all triangles have an angle sum of 180 degrees. So we can look at it as, well, it doesn't really matter because that third angle has to be the same as well. So for example, let's say instead I went ahead and said, instead of those marks, let's say I said that this was x and this was x and this is y and this is y and they're equal. Well, I know that with this mystery one here, okay, x plus y plus whatever that mystery thing has to equal 180. And the same thing is true from both triangles. They both have x and y, and the third side has to be the piece that's missing to make 180. So no matter what, they have to be the same thing, and it has to be whatever is inside those triangles. So what I want you to think about is I want you to think about a list of three things that a triangle has, remembering that, of course, it has three sides and three angles within it. What are the combinations of three, like angle, angle, angle? So one, for example, would be side, side, side. That's going to be all three sides of each triangle are the same. Remember, we have a total of three sides and three angles in a triangle. So try to go ahead and pause it and come up with all combinations you could think of. So the first one that I thought of was side, angle, side. And what that means is it means that you basically have, what that SAS combination means is you have a side and another side. And literally in between them is an angle. So it's side, angle, side. The angle, just like in the picture, is in between the two sides. We have side, side angle, which is when you have a side connected to another side, and then the angle is off of that. But we don't know how long it is, okay, because it's an angle. So that's a third one. We have angle, side angle, and that results from when you have an angle and another angle, and the side is in the middle of them. So you have side, angle, angle, and the side that's contained is in between the two. And then lastly, angle, angle, side, which is now you have an angle connected to another angle, and the side is not in the middle of them. So here's your first angle, here's your second angle, and the side is connected to only one of the angles. That will always result in angle, angle, side. So our task now is to look at each of those and figure out which ones of them could be guaranteeing congruence and which one of them is not necessarily guaranteeing congruence. So we're going to start off with side, 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 but before we do that, basically the way that we did this in class, and I know if you're at home doing this, so what will happen is you can actually print out the notes and they will have on there the stick lengths as well as the angles that you could then cut out and use for this activity. So you may need to pause it and do that if you haven't already. But this is something that we're going to do to investigate all of the different ones and figure out which ones give congruence. Okay, so the first thing we're going to do is we're going to investigate side, side, side. And for that, we need the 6 centimeter, the 7 centimeter, and the 10 centimeter. And all I want you to do is just make a triangle out of the 3 of them. The goal here is to see if I use these 3 sticks, will I get a triangle that is exactly the same no matter what. In a full class, this works really well because you can compare to all your partners. But for our purposes, it's still going to work. We just need to make sure that each person at home, when you're doing it, you just match it up to my triangle. So pause it and try to create a triangle. All right, so now that I've created my triangle, this is the shape of my triangle. And the question then becomes, is there only one way to do it? One of the things to do, since you don't have a bunch of people to compare to, is ask yourself, where did you have any choices? Did you have the freedom to move anything around? Were you forced to do this exact shape, or was there a possibility you could have switched things around? Try switching the sticks around. Try moving things. See if you come up with a different shaped triangle. The fact of the matter is you won't. Because of that, that triangle congruence can go on your list of things that are congruent. Side, side, side. When you have 2 triangles that have the exact same 3 sides, you can only make one triangle out of them. And that's kind of the point. The whole point of this activity is to say, when is just having 3 sides going to force me to have one and only one kind of triangle? Or when can I create more than one triangle with the same rules? Second, we're going to look at is side angle side. So this one I said use the 7 centimeter, the 10 centimeter, and the 40-degree angle, which is the narrower angle with the solid lines. So if I start off here, okay, the angle has to be in between my sides, which means I have to have the 10 on one and the 7 on the other. Okay, I could switch them, but all that's going to really do is flip upside down the rectangle. Now the question is, if I connect that side, is it possible to get only this one triangle, or could I possibly have gotten other triangles? What you should find is you have no choice. No matter what way you turn it, flip it, rotate it, you'll get the same triangle. And the reason is this angle down here, it really restricted my motion. I couldn't move them further apart. If I was allowed to move the red stick out to like here, well then there you go, I have a new triangle. But I wasn't able to do that because of the angle. That angle stopped me from doing it. Similarly, I couldn't like move this out here because then this stick would need to be longer. So the length of the stick also restricted it. And the same thing for the third one. I couldn't connect it that way because that length of the stick couldn't be shortened. So all of the pieces required me to create one and only triangle. And because of that, SAS is also another form of congruency. And we're going to look at how we're going to use these later, but it's saying that if a side, an angle, and a side occur in that order, then guaranteed you can only create one unique triangle. The next one on our list was side, side angle. Again, what we want to do here is we want to take the 6 centimeter, the 10 centimeter, and the 40-degree angle, and we want to try to create basically 2 triangles. If all we can do is create one unique triangle, then it's guaranteed a way to find congruency. If not, it won't prove congruency, and we can be able to create more than one triangle. So again, I start with the angle. Okay, this time I'm using the 10 centimeter. But then now the other stick has to actually attach to the end of it. So what I did is I tilted like that and I connected it. Okay. The question is, did you have any choices here? Okay. This angle is restricted because that's one of the angles we're using. But the thing is, this angle is not. I could have done any angle I wanted right there. Now, it doesn't mean I can do anything I want because I can't put the stick out here. It won't connect to the triangle. However, for this particular example, I also could have put the stick like that. If I do that, I create a new triangle, a second triangle using the same rules, which were a 40-degree angle, the 10 centimeter stick, and the 6 centimeter stick. Because I can create 2 completely different triangles, this is not going to prove congruency. Side-side angle is not an effective way, and it's not enough information. When you get problems like that say side-side angle, you're going to have to simply say not necessarily congruent. You don't know for sure. It could be, could not be, but it's not enough information to know for sure. So now the next one is angle side angle. What this means is I'm going to take the 6 centimeter stick, the 40-degree angle, and the 110-degree angle. I'm going to take the stick and I'm going to try to connect both of the corners of the angles. Okay, so it's right at the corner of the angle. That has to connect right at the corner. It's not like the angle can go out here and then up. No, it needs to go right to the edge as I did in the example there. Okay, so try to form a triangle out of that, and then hit play when you're ready. All right, so if we do that, you can see this one's going to have to go right on there like that in order for it to hit the corner, and the other corner is going to have to go right on top of there as well. What you should notice is you end up with only one possible triangle. In order for me to do anything else, I'd have to slide the angles around, and I'm not allowed to because the corner has to hit the edge of the stick. As you can see, the angles cross in only one place, so the only thing I can do is connect those lines and create one triangle. Anything else I do breaks the rules. Now the end doesn't connect to the angle like it's supposed to for angle side angle. What that means is angle side angle is another way to guarantee two triangles are congruent. And by that I mean if I have another triangle that has that same 40-degree angle connected to that same 105-degree angle, okay, with the same length side in the middle, I can guarantee that that will make the same triangle both times. That is what it says. Now the last one we're going to look at is angle side. So again, we're going to use two angles. We have to. This time though, the angles are going to be a piece of the same thing, but the side is not. So I'm going to start with one angle, and I'm going to use my side on there, okay, because it's got to connect to one of them. But instead of trying to connect the angle up here, okay, like we did on the last problem, now the angle is going to connect down here. Okay, so go ahead and try to make that work on the problem. This one might have given you a little trouble, and the reason is you're thinking, wait a second, that's not ever going to work. It needs to connect to the end of this, but down there like that. So what happens is you end up having to slide the angle in until it hits. Remember, this does not have to, you don't have to worry about this being overhang because these go on forever. So it's sort of like eliminating all these extra pieces and looking at just that triangle. The question is, could I have had more than one triangle, just like before? Well, the reality is it has to connect to the ends of that stick, and you can't really move it around. So for example, if I wanted this to go like this, well, now the angle has to change. That doesn't work. Let's say I wanted this to be wider out here. That doesn't work because now this angle is messed up. Let's say I want to keep the same angle, but I want the angle to start way out here. Okay, well now the length of that stick has to be extended, and that then breaks that part of the rule. So in order for all three of these things to occur at the same time, there is only one unique triangle that we can create. So now what we're going to do is we're going to add to our list. Okay, there are ones that do prove congruency, and there are ones that don't. The ones that do prove congruency are side, 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 which can also be hypotenuse leg, side, angle, side, angle, and angle, side. The ones that are not able to prove congruency are side, side, angle, and angle. So really, I like to look for the ones that don't work. When I notice it's one of the ones that don't work, I just say not necessarily congruent and move on. To talk about hypotenuse leg, what that means is if you have a right triangle, okay, so obviously a right triangle with a 90-degree in here. Okay, so if you have a right triangle, if you know that the hypotenuse and the leg on two triangles are the same, well, really, even though it looks kind of like side, side, angle, if you look at it, you've got a side, and an angle. Because it's a right triangle, every right triangle that has the same hypotenuse and the same leg will result in the same other leg. So it kind of ends up just being side, side, side. So really HL, hypotenuse leg, is a special version of side, side, side where you don't have to find the third side because of the fact that right triangles always have the same, side when two of the sides are the same because they all fall under the Pythagorean theorem. The last thing that we're going to add in here is another abbreviation. The abbreviation is CTCP. You might see other ones, like I saw one today that was CPCTC, I think. And it's all just short for something. What I do in my class is I say congruent triangles have congruent parts. The purpose of that is saying, okay, we've decided that three things on these triangles are the same. When that occurs, that means the entire triangle is the same. Well, if the entire triangle is the same, all 6 parts of it are the same. So once I know that I have 2 of the same triangles, for example, if I said, okay, these triangles have all 3 sides the same. Okay? By side, 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 okay, now I know that these triangles are the same triangle, even if they look different. So those 2 triangles are the same triangle. What that allows me to do now is I said, hey, wait a second, this is 30 degrees. This angle down here. Okay, that's 30 degrees. But I don't know what x is right there. Well, you can't just figure that out. But once you know the triangles are the same, then you can say, well, since the triangles are the same, the angles in the triangles must also be the same. And that's kind of the idea behind congruent triangles having congruent parts. Now, once you know that, any of the pieces can be mixed up. So, for example, if I didn't know that, but I wanted to know a side, well, once I know that they're equal, I would know the sides are equal. And that's sort of the process that we use. You're going to see in some of the proofs how that works.